Okay, Assalamualaikum. So in this video, I'm going to present some examples of sensors that are covered in your slides. So the first one is the strain gauge sensor, which is one of the active sensors. So in your slide, you have seen that this is a strain gauge sensor. So the sensor has its own default resistor. So let's call it R. And then if you provide attention, for example, you give this force. So if you give this force in this direction to your sensor, the sensor will experience a tension. So when it experiences tension, it will increase the resistance. So that's why you have the plus sign. But if you compress, means that you have a force underneath. The compression will cause the sensor's resistance to decrease. So it's minus delta R. Okay. Now, it does not generate an electrical signal itself. By passing a current through it, its electrical resistance can be measured by detecting variations in the current or the voltage across it. So based on that, we are going to measure the voltage. This is the construction of the circuit for you to measure the voltage when you have change in the resistance. Okay, so what I want you to focus on is how you get to this equation. Alright, so you have this voltage supply, and this is the voltage measured. So your sensor is here. Okay, I want you to focus on the positive sign of your V out. So if your V out has a positive sign on your right, it means that this combination here should be the first term. Okay, and then the one at the numerator is your R4. So R4 over R2 plus R4 minus, okay, minus R3 over R1 plus R3. Then this whole term multiply with your input signal. So the next slide is just showing on the calculation, and approximately you can get this term. Normally delta R is very small, so that's why we can ignore this term, and you will end up having delta R over 4R. Okay, so for example in this slide, you can see the plus minus sign here. So it means that you have to put this side first in the equation. So you start with the bottom one, R plus delta R over R minus delta R plus R plus delta R. So this is the term here. Okay, and then minus R over 2R over here. Okay, now compression means minus, so that's why you have the minus sign here. And then tension is stretching, so the stretching causes a positive resistance, so that's why you have the plus delta R. So you have to know what happened to the resistance during compression and tension. Okay, so initially I will just put a default value R, but you must know what happened to the resistance when you have these forces. Okay, so the next slide is showing another equation that you can use to calculate what is delta R. So delta R can also be calculated using this equation, where your R naught is the initial resistance, okay, the default resistance, G is the gauge factor, and epsilon is the strain unit deformation. And then epsilon is also equivalent to the mechanical stress over Young modulus. Okay, another way is this equation as well, where your strain deformation can also be calculated using delta L over L naught. This is the length of your strain gauge. Okay, so just take note on these three formulas, because sometimes I can give you this kind of information for the strain gauge instead of the circuit. Okay, so this is the first example, and you can see that there are 4 strain gauge sensors configured in a full bridge circuit, right? And this is the excitation voltage, and this is your output voltage. Okay, so the question asks to derive the voltage output equation V out, and assume that the default resistance is R and the change can be denoted as delta R, and then you are asked to calculate what is V out if you are given R equivalent to 350 ohm and delta R is 0.07 ohm. The voltage is given as 5 volt. So what is V out? Okay, so that's the next part of the question. Okay, so the first thing you need to do is these arrows here are indicating whether the sensor is in tension or compression. So this one is in tension, so plus. This guy is in compression, minus. Again, this one is in compression. Okay, So delta R, and this arrow is tension, so plus delta R. So look at the direction of the arrows. Okay. So next, take note on the polarity of your V out. Okay. So the plus is on your left hand side. So the arrangement of the equation should be this way, right? So this configuration should be the first term, and the bottom one is the minus, so R minus delta R, and then the addition of these two resistance, so R minus delta R plus R plus delta R, and then minus the bottom one is R plus delta R, and then the addition of these two, R plus delta R plus R minus delta R multiply with your VI. Okay, and then you can simplify, bring VI over, so you are left with R minus delta R, and the bottom one, delta R will be cancelled out. You are left with R plus R, which is 2R, and then this side, the bottom part is also left with 2R. Okay, finally you are left with this equation, and you can cancel the 2, and so the answer V out is equivalent to minus delta R over R multiply with VI. So that's the answer. Don't worry about the minus sign, because voltage can be negative or positive. Okay, so the second part of the question is asking about the value of the V out if you are given the values of the other parameters. So you just need to put the values in your equation, and you will get minus 0.001 volt. Okay, so that's how you can solve an example of a strain gauge in a circuit configuration. So next, let's look at the second example. So this time you are given the information about the strain gauge. It has a gauge factor of 1.8 and its unstressed resistance. It means that the default resistance is 250 ohm. So what would be the percentage strain required to increase the resistance to 280 ohm? So you are given the value of R after you put pressure on it. So it increases to 280, which means what is delta R? So delta R is 30 ohm, right? Okay. So you have to look back at the formulas. This epsilon is the strain unit deformation, which means that you need to find what is the value of epsilon and then change it into percentage. So what is the percentage of strain? Okay. So using this formula, or this formula, it doesn't matter, because you are going to find what is epsilon. Okay. So this is what you need to do. So epsilon is equivalent to delta R over R naught divided by the gauge factor. Okay, and delta R is 30 over 250 multiply with 1 over 1.8, and you get 0.067. Okay, however, this is not the answer, because you need to find the answer in percentage, right? So you need to change the percentage by multiplying with 100%, and you will get 6.7%. So that is the answer for this question. Okay, so that is the first part of the sensor video. So the next video, I'm going to present some examples on thermocouple and perhaps some other sensors as well. Okay, take care. Bye. Assalamualaikum.